Hello, students. Welcome back to Tuition Masters. And today we are here with another session for Grade 9 CBSE Mathematics, that is, a one short practice session for the chapter Linear Equations in Two Variables. So, this chapter it is the base chapter. You have to study it very, amazingly this year because in next year also you have the same chapter. Correct? You are going to learn more detailed things about it, isn't it? So, what we are going to do today is we are going to quickly revise the whole chapter and then we are going to solve some important questions based on them as well. So maybe in your midterms this chapter would be coming. So yes, we are going to solve this. So we know that linear equations you might have studied in your previous 8th standard also, right, where you studied linear equations in one variable, isn't it? Like uh, 2x plus 3 equals to anything. Let's take 10. So you have to find the value of x. Correct? That is how questions you used to solve in your 8th standard. That was in one variable. But this year in ninth and in the coming 10th, you are going to understand how do you solve questions with the help of graphs, and there will be linear equations only, but we are going to have two variables in them. All right, so let's see what we have to study. So this chapter is based on two major parts: linear equations and solutions of them. How do we solve linear equations? Then graph of linear equations in two variables, because two variable we cannot plot it on a number line. We have to obviously do it on a what we say, we have to do it on a graph paper, a Cartesian plane, and we are going to do some related problems with linear equations. Okay, let's start with the first topic of linear equations and solutions. So let's see here. When I talk about linear equation in one variable, it's very easy. As I said, it can be written in the form of ax plus b equals to 0. As simple as that. What is a and b? This a and b are real numbers. Okay, a and b are the real numbers and x is my variable. Just one simple variable I have, and I only have one solution. Okay, only one solution is present in the linear equation. In one variable I'll always have one single solution only. So every linear equation in one variable where the power is 1, it's linear, and it has only one variable in it that has a unique solution. If I say you uh 2x plus 3 equals to 10, what will be the value of x? There will be only one value. X will be what? 3 goes there, it will become minus 3, then 7. The 7 by 2 is the answer. So what is it? That is nothing but my answer. That's it. There won't be any more answers to it. Okay, but now talking about my next one, that is linear equations in two variables. I have three numbers a, b, c. These are my three real numbers and I have two variables x and y. Now this way when I talk about it, I will have infinitely many solutions. I can have many solutions. It will keep on going on. It won't have one single solution. Why? Because if I talk about one, will be like 2x plus 5y plus 10 equals to 0. So I'll take 10 to the other side. Now for x and y to satisfy the value, okay, of minus 10, what I will do? There will be many solutions for it, right? There can't be only one solution. There will be infinitely many solutions. I can take negative, positive, all the solutions I can take. So linear equation in two variables will have infinite solutions, whereas the equation in one will have only one solution. Alright. Now next one, solution of a variable. When I talk about solution, that is nothing but the value of variable which will satisfy the equation. That is known as the solution of linear equation. Whenever whatever the variable is being provided to you, the value of that variable, okay, the value of the variable is going to give you the solution. All right. Now, let's see a question. How many solutions does the linear equation 2x plus y minus 10 equals to 4x minus 7y plus 8 have? Now, you have to tell me how many solutions left. Common sense question, obviously it will have infinitely many solutions because these two equations, I mean this equation is the form of two variables, isn't it? So obviously it will have infinitely many solutions, isn't it? So Based on the first topic which we studied, let's solve few questions. Okay, let's solve the questions on the first topic we studied just now. Okay, now look here. Express the linear equations 3x equals to 2y in the standard form and find the values of a, b, c respectively. What are a, b, c? I taught you that when I talk about linear equation in two variables, they have a standard form as ax plus by plus c equals to 0. That is the one, that is my standard form of linear equations, okay, in two variables. Okay, now what we have here is we have 3x equals to 2y. Now what is this? It should be ax plus by plus c. Now what is this? It's just 2 3x 2y, that's it. Now how do I frame it? Now let's do one step. Can I take this 2y on the other side? Yes, I can do that. I can write it as 3x. If 2y goes there, it will become minus 2y. Okay, 3x minus 2y. Now, if I add a 0, it won't make any change. If I add a 0, the value still remains the same. And I will put the value as 0 because minus 2y I am taking to the other side. Now, what can you see? It is in the form, right? It's in the correct form of ax plus minus, it's fine. Plus 2y plus c equals to 0. Is it matching? Yes, it is matching. So what are the values of a and b? A, B, C. So a is equals to 3. You can see here. Then b is equals to minus 2. Okay, it's not 2. It will be minus 2. And value of c will be 0. So this 3x equals to 2 I can rewrite in the form of 3x minus 2y plus 0 equals to 0. When you solve the question, it will be the same only. If it's there is no change in it. Okay, there is no change, right? So let's see the next question. Next question is, age of father is 7 years, more than 3 times the present age of his son. Represent the above situation as a linear equation in two variables. So what we have to do is that we have given the age of father, age of father is 7 years. Okay, it is 7 years plus 3 times of the present age of son. Okay, so we need variables. Okay, let's say the present age of father. Okay, you have to write in the correct, I'm just writing it roughly. Okay, so let's say the present age of father. Okay, we do not know, we will take variables for both of them. Present age of father, let's take it to be x years. All right, similarly let's take for the son also present age of the son, let's take it to be y. Let's take it to be y years. All right, now what is given to us is that age of father means x equals to 3 times, 3 times the present age of the son. 7 years more than 3 times, right? So 7 plus 3 times of the sun's age, that is 3y. So what linear equation we get? We get that x equals to 7 plus 3y. If you want to write in the exact form, we will write it as x minus 3y minus 7 equals to 0. That is the linear equation. As you can see, that is my answer. Next question. The cost of a notebook is twice the cost of a pen. Write a linear equation in two variables to represent this. We have given notebook, the cost of notebook is given to us, and even the pen also. Cost of notebook is rupees X and cost of the pen is rupees Y. Now what is it given? Cost of the notebook. Notebook X equals to twice the cost of pen, that is 2y. Correct. 2y. And if I want to represent it, how will I write it in the form? So I'll write it as x minus 2y equals to 0. That will be my linear equation in two variables. Simple, isn't it? Okay. Let's see our next question. Sum of the digits of a two-digit number is 14. Okay, two-digit number, it is 14. All right. If we add 18 to the original number. What is the original number? If I'm adding 18, the digits ones and tens, they interchange their places. So we have to write two statements, two equations for this statements. All right, so let's see how we are going to do it. So basically what we are going to do, we are going to go step by step. All right, so if I talk about any, let's say 26. 26 is what? If I want to write 26, how will I write it? 26 is nothing but 10 into 2, correct? That is 20 plus 1 into 6, isn't it? Correct. Now if I want to flip the digits, it will become as 62. Correct. So that means xy, the value of xy, the two digits is equals to 10x plus 1y. Correct. 10x plus 1y is nothing but the number. Alright. Now if I want to interchange it, if I want to make the digits flip, what will it be? It will be 10y. Okay, it will be 10y plus 1x. Is it applicable here? Let's see. Here if you see 10, this is x, this is y. So it will become 10y means 10 into 6 plus 1 into 2. That is 60 plus 2, 62, isn't it? So what two equations we frame, that xy will be, the original digit will be 10x plus 1y, and if I want to reverse it, it will become 10y plus 1x. Okay, this is my equation I have framed. Now as per the question, what is given? As per the question, it is given that x plus y. Okay, the sum of the digits is 14. Sum of the two digits is 14. So sum of digits have given us 14. Let's take this to be our equation number 1. Okay, now if we add 18 to the original number is what? Xy. Okay, original number is xy. Xy can be written as 10x plus 1y. Original number, okay, plus 18. Original number plus 18 gives me what? It will interchange the places. Interchange means it will become 10y plus 1x. Correct? I'm just replacing it. As simple as that. I'm just replacing it. Okay. Now, what will happen if I do this way? What will be my next step? Okay, next step will be what? I can write it as, if I multiply it, what will I get? I'll multiply, I'll get it as 10x plus y minus 10y minus x, isn't it? And plus 18 also. That will give me the answer as 0. I'm transporting it. Okay, now final results will be what? Final results will be 9x minus 9y plus 18, sorry, 9y, right? Yeah, equals to what? 0. Simplifying it, it becomes 9x minus y plus 2 is equals to 0, isn't it? That's what I'm getting. Correct, that's what I'm getting. So let's see the answers what we get. So we are taking x and y, tens and ones place. Original number is x plus 10y. As we did it, sum of digits x plus y is equals to 14. Now when the digits interchange, when the digits are changing each other, the new number becomes y plus 10x. So x plus 10y plus 18 is y plus 10x. That is what we solved over here, isn't it? Here you see, this is what we did. Correct. So when you open it, what we get? Minus 9x plus 9y plus 18, that is 0. If we divide minus 9 both way, what will I get? X minus 1 equals to 2 and x plus y equals to 40. These are my two linear equations. Okay, now moving towards the next set of learning outcome, that is graph of linear equation in two variables and problems related to it. So when I talk about linear equation in two variables, as I have two variables, I can plot it on the graph known as the Cartesian plane. Correct? I can only plot it on the Cartesian plane, isn't it? So let's see. Now listen to my steps carefully, what I'm saying, right? So every point whose coordinates satisfy the equation on the line. Okay, every point, whenever I draw a line, whenever I talk about linear equation, so linear equation will always have a straight line in the, uh, you know, straight line on the graph on the Cartesian plane. Talking about quadratic equation, it will make a parabola. All right. Now every point whose coordinates are satisfying the equation will lie on the line. Okay. These, if you see, if I give you equation, when you plot a line, so every point which comes on the line will be the solution. Okay. Now every point a comma b on the line gives a solution, and that is x equals to a, y equals to b, right? A is abhasaka and b is ordinate, so any point which is not coming on the line will not be the solution, as simple as that. Graph of linear equation is what? Whenever a linear equation in two variables is represented graphically by a line, the points will make up the collection of solutions of the given equation. The solutions will be given. Okay, now let's see a question. Is 2 comma 5 be a solution? Okay, is 2 comma 5 be a solution of the line shown in the graph? Now here you see, where will 2 comma 5 come? I'm marking it with red. Let's see, where will 2 comma 5 come? 2 comma 5, 2 is here, 5 will be here. So this is 2 comma 5. Now is there line passing through it? Line is not passing through it. So that means obviously no. 2 comma 5 is somewhere over here. So that's why what can I say? No, 2 comma 5 is not the solution. Now, next is, so the line of the equation x equals to a will always be parallel to the y-axis at the unit of a units from the y-axis. Now, what do I mean here? See this. Listen to me carefully. Whenever I have the value of variable a units is value of the x variable. So that line will always be parallel to the y-axis. Okay, this is my parallel line. Okay, it will always be parallel to the y-axis. Okay, if x is equals to a, x equals to a, parallel to the y-axis, and distance will be again a units. We are going to solve questions, right? Now let's see here. The equation of line x equals to minus 5 will lie on which side of y-axis? Left side or right side? So basically, when I say, it will obviously be on the left hand side. Correct. Now here you see x equals to a. X equals to a. Now if I say a is greater than, sorry, a is less than 0, because minus 5, right? So minus 5 is greater than, sorry, less than 0. So what happens is, that becomes lesser, so it will be on the left hand side because it is negative value. Okay, now next look at here. When I talk about line parallel to the x axis now, okay, talking about x axis, so when I talk about that, a line equation of the form y equals to, now if my y is equals to a units, so that will be parallel to the x-axis. When the value of x is given, it will be parallel to y-axis, and when the value of y is given, it will be parallel to the x-axis. Okay, so again it will be at the unit of a, at the distance of a units, the line will be parallel. If it is positive, value of a is positive, it will be above the x-axis. If it is negative, it will be below the x-axis. Now look here, the equation of the line y plus 3 equals to 0 will lie on which side? Now can I find the value of y from this? Y will be what? Y will be minus 3. Minus 3 means obviously it will be below the x-axis. Alright, so that is all about the theoretical part. Let's solve few questions now. As per whatever we studied till now, we will solve few questions. Now look here. Show how x minus 2, x equals to minus 2 can be represented graphically. Now what is given? X equals to a is given. Correct. That means the line, it will be parallel to which axis? It will be parallel to the y-axis, isn't it? Then what we have to do? We have to plot it graphically, isn't it? We will plot it graphically. Now let's see how we will plot it. So we'll try to plot us. We'll make a small graph and represent x equals to -2 there. Okay. Now look over here. Look over here carefully. Let me plot it. So see here. Starting from here, I'll make a small graph. Okay, a small graph. Okay, that way. It's a small. I'm making it roughly. Okay. Now here you see, which is my y-axis. This is my y-axis, and this is my x-axis. Correct. है ना? Now see, origin. This is my 0. This is 0 point. Then I have 1. I have 2. I have 3. Okay, I'm just drawing it a smaller one. This is again 1, 2, 3, and 4. Correct. Next here also 1, 2, and 3. Okay. Next on the other side also the negative part, -1, -2, -3, -4. This is my graph I have drawn. Now what I'll do is that I have to plot what was the value. Now, what was the value of my x? X was given as -2. X is -2. Where is -2? This is my -2. Right? This is -2. So that means what will be the value? The value will obviously, the line will uh, pass through 2. Correct? It will pass through 2. And the answer will be what? Answer is that x equals to -2. X equals to -2. Coordinate, what are the coordinates? 2 is coming, so -2 comma 0. That is the coordinate. Okay, that is my coordinate of the graph. So here you understood that how do we plot it. So here if you see in the exam, if I may ask you, so you have to use your graph paper. Here you can see how I plotted it. Now next one, the force exerted to pull a cart is directly proportional to the acceleration produced in the body. Express the statement as a linear equation of two variables and draw a graph of the same by taking the constant mass equal to 6 kg. Read from the graph the force required when the acceleration is 5 meter per second square and 6 meter per second square. Now what you have to do? Little bit physics, maths plus physics we are doing today. Okay, so this is a maths plus physics question. Okay, so let's see how we're going to do it. Now we know force. Let's take force to be F. Okay, force to be F. F is given to us as directly proportional to A, that is my acceleration. Okay, now we know that force, we even know that force is nothing but mass into acceleration, and I know that we have studied this from our chapter force and laws of motion. I only taught you that, isn't it? So yes, force is equal to mass into acceleration, we know that. Correct. Now what is it given? Mass is given to us as 6 kg. In the question it's given that mass is 6 kg of the object. Okay, mass is 6 kg. Now first case, for what will be my force now? If in this condition I speak, what will be my force? Force will be nothing but mass into acceleration, that is 6, and acceleration we do not know. So F equals to 6a is my thing I'm getting now. Now, taking the first one, if my acceleration is 5 meter per second square, if a is equals to 5 meter per second square, so what will be my value? From equation 1 we can say that force will be nothing but 6 multiplied by 5, that is 30 units Newton. Okay, similarly for the second one also, acceleration is 6 meter per second square. So what will I get? Force is equals to 6 into acceleration, again a 6, that is 36 Newton. Okay, 36 Newton. Now is the question over? No, it is not over. So what will be my coordinates now? I have to plot it on a graph also, remember? So what will be my coordinates? My coordinates will be what for this one? It will be for my first one, it what will be the 2 points? It will be 5 comma 30. Correct. 5 is the acceleration, 30 is the force. Correct. Similarly for the next one, it will be 6 comma 36. All right, this is my thing. Now what we have to do, that we will plot a graph on it. Okay, we will plot a graph of it now. Now Here you see I've already plotted one graph. Okay, so now what we have to do is that what were the coordinates? Our coordinates were 5 comma 30 and 6 comma 36. So 5 comma 30, where will that lie? Let's see. 5 comma 30, right? 5 comma 30, it will be over, yeah, it will be here, 5 comma 30. This is my 5 comma 30, isn't it? And next one was 6 comma 36. So 6 is over here, 36 will be somewhere over here above 35, isn't it? Now what we'll do, I'll plot a line from them. Correct, I'll plot a line between them. Correct, so the line we will start, correct, it will go through them. Okay, it will go through them. Correct, so these are my points on the Cartesian plane, right? What were the values? Let me write it also. The values were 5 comma 30, correct, and here it was 6 comma 36, isn't it? These are my values. So here you see, this is your solution and this is your graph also. Next question is, Lipsa and Mona are two students of ninth class of DAV school. Together, they contributed rupees 100 towards the old age home to help the old people. Write a linear equation which will satisfy the given data and draw a graph also. So, you have to draw two things. I mean, not two things. You have to draw a graph and we have to and we have to write a linear equation. Now, again we have to do variables and all. So let's say this is a 4 marker question, so listen to me carefully. So let the contribution, so first one is lipsa, so let the contribution of lipsa, first one is lipsa, how much she is, let's take it to be x rupees, x. And similarly let the contribution of Mona, let for Mona be y, x and y rupees. Okay, now what is it given? Together they contributed, together as an addition, x plus y equals to 100. Correct, given. What will be my value of y then? Value of y or x, anything you can find. I'm taking y, taking x over there, I will get it as 100 minus x. Correct, I've got two equations over here, right? Now there can be infinitely many values of them. Correct, there can be many values. There can be, like, for example, let me draw a quick table. So here you see we can take any way, like if we take y to be 50, y, if y is 50, using the equation x will also be 50. Correct, if x is 60, y will be 40. Correct, then if x is 40, this will be 60. So there can be infinitely many solutions. So we want the we want the equation, so we have written this. Now for as per related to graph, I will show you. So see, we can use many values, 10, 90, 30, 70, 50, 50, 40, 60. Many values we can put to make 100, isn't it? Now here you can see on the graph, as you can see the graph, that way you can plot it. I'll not draw the graph because it's easy. Just use the graph taking 10 as the scale, right, and plot the points. Okay, so which will make up 100. Next question, moving towards the next question now. The path of a train A is given by the equation 3x plus 4y. Okay, 3x plus 4y minus 12 is equal to 0. And the path of another train B is given by the equation 6x plus 8y minus 48 is equal to 0. Represent the situation graphically. So graphically, I'll show you my graphs. Okay, but before that, let's try to find the values of y and x. Okay, so look over here, we can just do a partition. Okay, do a partition. Now look here, first train, first train is given as 3x plus 4y minus 12 equals to 0. All right, now let's take 4y over here, that will give me 12 minus 3x. I'm transporting the value, and value of y will be what? Value of y will be 12 minus 3x whole by 4 first. Correct. Similarly for train number B, 6x plus 8y minus 48 equals to 0. Taking 8y, okay, taking 8y, that will be 48 minus 6x, and again y value will be what? Y value will be 48 minus 6x whole divided by 8. So I'm getting these two values. Now you see here, based on that I can frame it both the answers. Now what values you will put? You can put value. If x is 4, y will be 0. If x is 0, y will be 3. You can use them. Correct. Similarly for train b, you can use x is 0, y is 6, x is 4, y is 3. You can use them. Correct. And then you can look over here that how will you plot the graph. Now you know the point, so remember that both the lines will always be parallel to one another. Okay, that you will notice that in this graph both the lines will be parallel to each other. Alright, so yes students, thank you so much for watching today's session. This is all about today, and we have completed the chapter linear equation in two variables in 30 minutes with important questions. I'll be seeing you very soon in the next video. Till then, take care and goodbye.